Anybody else? Anybody else have any thoughts or additional resources they want to share?
I'll share one. This is Mike Clyde from Cypress College.
Hey, Mike, how you doing?
I'm part of a small T10 instructor community team that created a safe labs project, and we're going to be presenting on Tuesday, August 4th at the ASC online seminars on how to get back into lab and have safe lab protocols in the COVID-19 environment. And all the materials we develop for the T10 instructors will be made available to everyone across the country to adapt to your situations. And I went back to lab this week, so it should be a good presentation and discussion to help everyone get back into lab as safe as they can.
Wow, that's cool. Mike, could you put that information in the chat? So
I will.
that'd be great. Thank you.
Sure.
Larry,
Yeah.
how are you doing?
Hi, how are you?
Good, good to see you.
So there's a number of people in my region in Southern California that would be very interested in that safety group's product. So whenever you all are ready to share that information, please make sure I get it so I can get our faculty to benefit from that as well. If you would like us to benefit, we'd appreciate it.
Great.
Yeah, I saw some of the PDF stuff that they had put together, and it was pretty good. And if you do a quick Google search, I'll have to find the link and I'll send it to Pam and stuff. There was I think it was a community college in British Columbia that had just recently gone back and had some real interesting lab layouts and things like that, you know, kind of using the welding screens and stuff like that, that, you know, kind of brought to life some of the stuff too. It's only a few-minute video. I can't remember the name of the school, but it's a British Columbia Automotive School, you know, COVID return or something like that. You can probably find it through YouTube pretty easily, but I'll get that link to Pam.
Cool.
It is the British Columbia Institute of Technology.
Perfect. Thanks, Eric.
Sure. Thank you. Thank you, Eric. So welcome, everyone. This is our ADAS training number 6, and we're going to be focusing on driver drowsiness detection, rear cross traffic, and night vision systems today. As always, please mute yourself during the overall conversations and presentations. And if you could, announce yourselves in the chat. And if you have any other resources or ideas that you'd like us to focus on in future webinars or conference calls like this, please also put those in the chat. And I will now turn it over to Kurt. Kurt, thanks again.
All right. Let's see if we can get this to work today. Let's see here. Now, hopefully everybody sees the screen with our main page as always. Go ahead. Go ahead.
Sorry, everybody. I forgot one other announcement. I received an email from a special group regarding women in technology, and they're looking for 4 automotive programs to your colleges that would like to participate in a grant-funded online women tech automotive recruitment and retention training and coaching. It's free based on a grant. So if anybody is interested in recruiting women, I will introduce you to Donna Milgram, who is running this program. She had a very successful project with City College, and there's a case study on what they did at City College's auto program. They were able to recruit 7 women students for their pre-apprentice program last year. So if you're interested at all, it's free, and it will help you to recruit more women into the automotive channel. So please put that in the chat as well if you're interested, and I'll send the information out to you. Sorry, Kurt.
No, it's all good. So one thing I realized the other day is I think a lot of the time when I've been talking, I've got like 5 windows open on my screen and usually about 1 strip of the pictures. So I know I call on Mark a lot because I see his hand waving. So for some of the others that may have had their hands waving, I wasn't ignoring you. I just never saw it and I didn't really think about it. So make sure you throw the questions in the chat thing big time, and we'll try real hard to catch it there. And if it's something you need to say when we hit the chat, you know, go ahead and free your mic up and go ahead and let it go. So today's the 6th of 9, so we've still got a couple more weeks to put up with me. Driver drowsiness is kind of an interesting topic, rear cross traffic, and night vision. So it'll be some different stuff. Some of these things are fairly new. Some of them are pretty old still. as we're seeing. Somewhere around the hour and a half as usual, depending on how the discussions go. And remember, there's no right way to do all this stuff. It's whatever works best for you. Focus on whatever tools, equipment, vehicles, things like that that you've got. We're not trying to get real deep. We're just trying to certify you. We're just trying to give you an awareness. And right now, this is a huge discussion. I've been on some other calls for the fleet side of this, because heavy duty truck, off-road industry, all that kind of stuff, they're in the same boat, except for a lot of their technology isn't even as far along as ours. So their technicians are really making an 80s to 2000s jump, all in one fell swoop, as ADAS and EV and things like that come into play. So you will see some other avenues there, and one of the discussions is how are they going to help get in their technicians up to speed, because heavy duty has little to no training systems and very little aftermarket training and very little industry-based training, manufacturer-based training. So one of the things that I've been kind of mentioning to them is there's a lot of crossover between automotive fundamental, hybrid and EV, as well as ADAS. And it may be an opportunity for your programs to take something like your existing hybrid and EV class, take some of that content out and focus it down to battery basics, converter inverter basics, motor basics, some of those general control and operational things, as well as safety, obviously. And now you could create a industry-based course to support collision, heavy duty, and even automotive industry guys who have no foundation. And you can take them through a fairly high level using what you already have. It's not so much about learning on a Prius. Who cares? The Prius just happens to have the stuff on it that you're talking about. It's when they get beyond that, when they have to go work on that EV bus, that they need a bus. Things are just bigger, heavier, and what have you. So there may be some opportunities in this. One of the things I've been talking with these groups about is how we can kind of use stuff we already have in a lot of our programs and open it up to a whole nother audience. And ADAS fits right into that too, because you already have a huge push in the heavy duty industry with ADAS. They've already got it on a lot of overland trucks. And the trucking industry is very aggressive about bringing on semi-autonomous and autonomous. Navistar, which is a huge truck company, just went into partnership with an AI company for autonomous vehicle development. So there is a huge momentum there. So as we look at challenges with recruitment in our regular programs, here's another opportunity to maybe create some industry classes, contract ed type classes, things like that, to help support a program, fund equipment purchases, and give you crossover between your existing automotive programs, a collision program, heavy duty students, industry technicians, because this entry level foundation awareness basics, they all need. So just something to think about. Again, Steve, Zach, and Bosch were huge on providing stuff for us to pull all these things together. So you can access all that fun stuff up on the site. Remember the ATL site? That's where all this is. It's actually under a curriculum. There's a first tab there, which is ADAS webinars. The video goes up as soon as she gets the video, and the PowerPoint presentation goes up with slide notes. You have full access to it. I had a gentleman in Southern California who's involved with ASCCA real high. He wants to share it with the ASCCA people. And he asked me if he could. I said, sure, it's public stuff. So that's another avenue for even some of your advisory members, and say, hey, here's some stuff. It may not be for a technician level necessarily, but it gives them an awareness that they may not already have. So just tools to use. So let's talk about driver drowsiness detection. One thing I found was when I drove a very highly, ADAS supported vehicle, your brain kind of tunes down. You're not paying as close attention because, you've got active cruise control going, you've got lane departure going, you got blind spot going, and you're just kind of point and shooting at that point. And it's a little easy to get a little drifty in the brain. And if you're on a long enough drive, this starts to come into play. And plus those of us who commute, you're up at 4 or 5 a.m., you drive for an hour and a half or whatever in nothing traffic. This becomes a bigger play. So drowsiness detection is something that's pretty interesting. I'm going to show you two different video clips. One of them is going to be algorithm based, and one of them is going to be camera based.
Improvements in comfort make even long journeys in a Mercedes a pleasure. During long journeys, however, it is possible that a driver's attention level will fall. Many serious accidents are caused by drivers suffering from tiredness. To help recognize the signs of driver fatigue at a very early stage, Mercedes-Benz has developed Attention Assist. If the system detects these typical signs, the driver will be urged to take a rest. During the first few minutes of driving, Attention Assist draws up an individual profile of the driver's driving style, which is then constantly compared with the latest feedback from the sensors. At the heart of the system is a highly sensitive sensor that records steering movements and steering speed. Studies by Mercedes-Benz have revealed that drivers who are tired will keep making minor steering errors, which they then usually correct immediately. If the system detects this sort of behavior, it will go on to check further relevant parameters in order to verify the result. For example, how long has the driver been at the wheel? Is the driver using the instruments and thus showing signs of activity? Are there external influences at work, such as side wind or an uneven road surface? If the result is unequivocal, Attention Assist will issue the audible and visible prompt, "Time for a break." Attention Assist from Mercedes-Benz helps prevent accidents caused by driver fatigue.
So that one's algorithm based. It's not using a camera. This next one's using a camera, and then we'll go into some questions that come up. Different ways of going about it. So what are we trying to accomplish with driver's detection? If you start to get a little sleepy, if you start having some erratic motions, it's now looking at, hey, this person may not be all there, may not be paying attention the way they should be. Let's do something to wake them up. So give them that warning and things like that. You know, obviously, if we can keep people a little bit more alert, there's less chance of accidents, less chance of injuries, all that kind of fun stuff. Whether we're using sensors or cameras or purely algorithms, it's much more of a passive system at this point, but it wouldn't take much, a couple lines of code for that system to become active. And if you've got this system along with things like a lane departure, the system becomes a little bit of an active system at that point, because now lane departure is going to kick in as you start to drift around. Or if you've got lane centering, it's going to help keep the vehicle straightened out a little bit. So there's some interesting aspects to this that have a lot of overlap with other systems. So again, we're using a camera or algorithms. And one of the things that I thought of with the algorithm one, because it's very much looking at speed or at steering sensor input. So steering angle sensor is going to be a huge input with this. What if you've got a shaky hand driver? Somebody that's got that vibration in their hands all the time, it's going to be looking at that, statically input all the time. Well, theoretically, if it's creating a template for those first few minutes when you're driving, thinking that you're more awake, it would see that normal input variation. And it's when you get tired that it would see an abnormal input variation. These systems, when they first came out, they were notorious for the coffee cup instrumentation and identification. Hey, get a cup of coffee, pull over, relax, things like that. Typically, it was an audible, not so much a heptac, but it could be. But one of the things that I started to wonder is, what if my driver's wearing sunglasses and it's a camera-based system? How is it going to function? What if they just wear regular clear glasses? Because we all know, and you can see it on my face right now, because of the way the lights hit the lenses, the way the computer screen hits the lenses, the reflection. So how closely is it looking at my eyes for blink rate and things like that? What if I'm one of those drivers that you see that have the big green sun shield in front of their face? So these are some things that, from a technician standpoint, when you go road test the car, you come back and say, hey, this thing works fine. It's making sure that our service advisors and our technicians, and even especially our customers, understand that, hey, when you're wearing sunglasses, it can't work right because it's looking at your eyes. Or if you've got that shield on or things like that. So there may be conditional situations that the system's not going to work the way it should. Customer's going to perceive that as a problem, and they're going to have a complaint that's going to come in complaining about it. But from the backside of it is understanding how this thing's really working, how it's really looking at it. So is one better than the other? It's probably a combination of both. What was interesting with the algorithm one, though, it does take into consideration those other influences. You're on a gusty road, you're going to have a correction factor that's different than if you're just driving down a straight, flat road. What if on one of these camera-based systems, because a lot of the early ones would locate that camera right in front of the instrument cluster on the steering wheel housing. So basically you had that piece that came from the dash to the back of the steering wheel, and they would have the camera mounted right there. Well, if that camera is located in that location and you're not sitting correctly to where you're in that camera's line of view, it may not react correctly. What if they put a different steering wheel on it or something like that? The Subaru one looks like it's more in the navigation monitor, so it's looking a little more off angle at the driver, probably less susceptible to blockage, because with some of the driver ones, with some of the cameras mounting on the steering wheel column, if you had your hand located at, say, 12 o'clock, you'd be blocking that camera view of your face and things like that. So it might not pick up correctly then. So understanding some of those aspects would be really important for the technician to be questions to ask, for the service advisors to ask, and may have to require some re-education of the customer to understand how the system works and how to make it continue to work based on their driving. Components in this thing, it can be a camera or it could be just module algorithm based. We're going to be looking at steering angle sensors primarily, but you may also have input from lateral accelerometers so that it can pick up gust and wind. The system could be looking at wheel speed sensors for variations if you were winding and driving through the road. I like to start to use more and more of these flowcharts, and these are old technologies for us. And a lot of the factory diagnostic equipment has taken these, paper flowcharts and embedded that into the diagnostic system. So if you get a fault code and you start going into the diagnosis on that system, typically what it's doing is it's running you through that flowchart. It's looking at, hey, does it see this sensor? What's the value? Does it see that? And it's making that flow for you through the diagnostic chart. But getting the students to think about these can help them start to improve on their diagnostics. It also forces them to understand the system's function better. The cameras and stuff, a bunch of us went to San Jose about a year and a half ago, and went down to that technology center for a tour. And there was one of the companies that was there, and their whole focus was on physical imaging. And it was being used in automotive applications and airport security and all these different things. And they were using it for picking out, threat potential things. Are you happy? Are you mad? Are you sad? Whatever. And it could pick those things up. Well, essentially, that's kind of what this camera-based system's doing. It's looking at changes in your face, yawning, blinking of your eyes, things like that, because that is the cues that that system has been taught to look for. So again, really understanding how these work are going to change a lot about how we diagnose. Now, diagnosis, if it's a camera-based one, we've got to look for damage to the camera, and we might also take a look at customer-caused problems. Some people store their mail on the instrument cluster. I've got a guy around the street from me. His car, other than the driver's seat, is level to the glass. Back seat, front seat, dashboard. That's not going to work. Now the technician, what are you going to do? You're going to get in there. You're going to take all that out. You're going to drive the car, and it's going to work fine. What's the customer going to do? They're going to stuff it all back in there, educating them on, hey, you got to leave that out of there. Fault code chasing, our powers or grounds or signals. I got a diagram that's going to come up in one of these other ones to where it really reinforces exactly what I've been saying with those three things. So understanding, that's the biggest thing, the biggest term I want to use today is understanding. The more they understand, the faster it will be, the better they'll be able to diagnose, and they'll be also to be able to make that decision of it's not broken, it's you, and re-educate the customer. And you can see this is one of those camera-based installation locations. If you had a driver drives with their hands at 12 o'clock, they're going to obscure that camera. These kind of things come into play. If you have customers who, I think on that Subaru, because it looks like it's coming out from that the navigation screen, maybe they put a phone holding clip in the vents near it, and now their phone's in the way. Or they got a bunch of stuff hanging down from the rear view mirror and it swings in front of it, their work badge, stuff like that. All of those different kinds of things could be an issue when it comes to diagnosis. The good thing is really not going to be a lot of calibration. The camera mount setups that I've seen, it's pretty much a fixed thing. It's mounted. There's no adjustability to it. I don't know on the Subaru if there's any capability within that, but there's possible. Otherwise, there's nothing special you got to do. It's kind of a use it and go type of system. So let's see what we've got in here. This one's kind of a straightforward topic. Steve K, first system will monitor uneven road surfaces, then it'll monitor ride height to determine an uneven road. What it's looking at is it's looking at a lot of different things. It's not so much looking at uneven road or ride heights and things like that. It's really looking at what are your normal inputs. So when you first start driving, it assumes that you're awake and alert. And your steering inputs, typically when you're awake and alert, are going to be less. But if you're on a rough road or in a windy condition to where you're having to make corrections, your corrections are probably going to be kind of smooth and, as necessary. But as you doze, you stop having those little corrections and they become jerk reactions. As you start to go, oh crap, and it becomes a different response rate. I'll use the term frequency. Your frequency changes based on the road conditions and atmospheric conditions. Mike mentioned, does Subaru say you can't wear sunglasses in the owner's manual? I haven't looked, but I wouldn't be surprised if they did say the system may not work properly, correctly, if you're wearing glasses and things like that. And I know there's a couple schools that have Subaru in their program. So if you've got that and you're aware, throw it in there. But it's something I thought about this morning and just didn't get around to looking at.
Can you use different filters on cameras to see through sunglasses, and you can do it to knock out glare?
You probably could. Whether they are or not, I don't know. I truly don't know what they're doing with their cameras. Pam's shaking her head no, because I know she sat into some of the Subaru ADAS stuff one day.
Yeah, I went through their master mechanic training per vehicle dynamics and ADAS systems end of January. And they did not mention the special filters on the cameras at all, or that they were doing that. So I doubt that they have continued down that pathway.
Yeah, so interesting to find out. If I'm working on Subarus and I got complaints that relate to that, I'm definitely going to make the effort to find out more. Ed mentioned you may not be able to fix the vehicle because it's operating as designed. You may need to fix the customer, educate them on the system operation. And that's a huge line. If you've ever worked in a car dealer in the last 20 years as technology came in, customers come in that first 1,000 mile, 2,000 mile inspection, and they got 62 lines of complaints. There's 3 things really wrong, and the other ones are all operational. They don't know how to use the buttons. They don't know how to program the radio and all that kind of stuff. So you, as the technician, you still got to go through and make sure there really isn't a problem with those things. And the last thing you want to do is, give that customer that unable to duplicate or normal at this time, because in their mind, it's not. So by taking that few extra minutes to explain to them how it works, find out more on maybe how they're using the system, where they're wearing the glasses or they're wearing a face shield or they got things hanging from the mirrors, to where how that could be the problem. And then once they're aware of that, that complaint goes away. But if they leave and they experience it as they left, they're going to turn around and now it's a second attempt. We need to keep that lemon law mindset in life, because the reality is they come back in complaining about that same thing and you tell them it ain't broke. They leave again. It comes back a third time. And with almost every manufacturer out there, you're now telling your field engineers that, hey, this is the third attempt on something. And they get real nervous because now they're talking lemon law and buyback. So being proactive on that education of the customer is huge. Let's see here. Kaylin, switching drivers without shutting down the vehicle. Yeah, that would be a big issue, especially on that Subaru one, because it was recognizing you via camera, via facial. And if you noticed, it was also personalizing it to you. A lot of vehicles have had personalization based on the key or the remote that you open the car with, and it'll do mirrors and radio stations and climate and seats and things like that. But this one was actually looking at the driver. So I partially wonder if I could go in there, say the car is still running, go in and select a new driver that already has a profile in it. If it's one looking at algorithms, that's a whole different ballgame, because everybody probably drives a little bit differently. And you might get some false positives on a system that's, Pam drove the car first, it learned her algorithm, and then somebody got in after her and drove it differently. It may not recognize that algorithm, and you may get some false positives on that. So that's a real good question, Kaylin. Let's see here, Mark. How does this heightened CAN communication affect current draw, alternator amperage, or even electric vehicle battery consumption? Well, that's a big thing. The consumption issue is huge on cars. I'll speak from BMW, that's just most of my recent stuff. We were sucking the life out of batteries. Our charging system was really designed to charge on D-cell. Well, there's not a lot of D-cell in stop and go driving. So you tended to run a lot of negative battery stuff, and trying to address that in later systems, what they've started to do is go to as low as operational use as possible. So historically we had a 12-volt relay, we turn that relay on, and we're still providing 12 volts and whatever decimal point of amperage to keep that relay on. What they've done on a lot of these newer systems, and I saw a brief blurb on somebody was doing a webinar on new electronic reduced usage. And what they're now implementing in a lot of newer cars are what they call a bistable relay. So basically that relay, it gets powered, it switches, and then the power goes away and the relay stays engaged in that position. And then they power and they switch it the other way, and then it turns off and it stays in that position. So it's not like the traditional Bosch relay where it's only on as long as the electromagnet's on. Well, think about how many relays we have in a car. If we can knock out all that from a bunch of those relays, maybe we knock out a couple of amps. And as we go to more LED interior, exterior, all that kind of stuff, now we start to change that. They've changed how some of the modules are being powered. The modules are going into some sleep modes, like door modules that used to stay, wide awake all the time waiting. They kind of go into a standby mode and things. So there's a lot of things that the vehicles are doing to go into energy conservation. Go ahead, Mark.
So what I was actually kind of leaning towards was an autonomous vehicle. I haven't paid much attention to the ones I've seen at some of the seminars we've been to, but how do they deal right now with autonomous vehicles and the current that they need? Do they have huge batteries on board? What modifications they have?
Well, a lot of these cars, they're born with this stuff. I mean, when we think about a modern EV, these things are already on that car at birth. So it's not like we're taking a 2010 Chevy and we've decided how are we going to engineer these things into that car and move that technology forward. Basically with the EV, they started a clean slate and they're saying, we put this stuff on to begin with. But yeah, the more of the features you have, the more draw you're going to have. But as we improve efficiencies, you see more and more aggressive regens on the EVs now. And a lot of these systems are going to be designed and already are designed to be low consumption. So they're drawing as little as they can. And probably with some of the things, if I need to keep the radar pounding away all the time, then that's something I got to keep lit up. If it's a camera, it's something I might have to keep lit up. But there may be some things that I can put into a standby mode so that they're ready to activate when I turn on the turn signal, or they're ready to activate when I go into reverse or to park and things like that. So I think it's a combination of both. Plus, we're starting to get to those battery numbers on a lot of these cars. Most of the new cars we're seeing 200 to 250 to 300 mile ranges and some more. There's less concern on the range impact because they're already going farther. If I'm in an old Gen 1 Leaf and I get 60 miles in the summer, I'm much more concerned about it than I am in a Model 3 that's going to get me 300 miles in the summer. So those come into play. If anybody saw, Nissan's got a new EV crossover that they announced, the Aria, two-wheel drive, all-wheel drive, up to 300 mile range, liquid cooled battery finally. And it's going to CCS instead of CHAdeMO. So it should be interesting as well. Let's see here, Don Moore. How about seat angles? Can they tilt back and lay down? Yeah, I joke with my students and say, hey, nobody's shooting at you, sit up. Okay, so yeah, seating position is going to be huge. If it can't see your face and it's a camera-based system, it's not going to be able to pick up. Now, what I don't know and I can't answer is if it's a camera-based system and it doesn't see your face, what kind of prompts does it give? And the video just briefly talked about one to where, as part of the calibration, part of the learning, it has to see your face. It tells you to hold your face in a certain position for a certain period of time. And then they did just briefly show like a warning indicator that essentially said, I can't see your face, all right, or you're not in the picture. So I think if you're in a vehicle that has a camera-based one and you're not in its view sight, it's going to give you a prompt to see you. And if you still choose to lay down and drive, then that system's just not going to work and you're going to have to deal with whatever lights and buzzers at that point. Ed, I wonder if it may use seat occupant detection, Matt, to see if you're sitting squarely in the seat or slouching or leaning side to side. Yeah, that could come into play. And again, it's just another line of code depending on how advanced their seat mat is. A lot of seat occupancies are there's something, there's nothing. Or the modern ones with the multiple pressure sensors, so they start taking a picture of your butt basically and saying, yeah, this is a person, this is a child, this is a bag of groceries. But that's another one of those things. We talk about these sensor integrations and sensor fusions. That's a possibility that could be written in behind it somewhere that they just don't talk about. Mark, my mom would pull the choke knob out and hang her purse there. Yeah. Customers do things and they just don't understand what the impact of it is until we educate them. Good thing it wasn't a hand throttle. Isn't that where the choke knob was for? Okay. Ed, electrical energy reduction logic of creature features such as seat heating not have a priority over safety systems. Yeah. And that's another big piece with these systems on these cars where you now have to register a battery when you replace the battery because it's going to change how it changes the charge rates and things like that. A lot of those cars also have energy consumption programs and profiles to where they'll say as the battery voltage comes down, it will take the seat heater from a high to a medium, or from a medium to a low, or even pulse it. Same thing with the rear window defroster and stuff. So there's a lot of things some of these newer systems can do to go into these energy reduction protocols. And you can actually see that on some wiring diagrams. You'll start seeing, you know, maybe they call it B+1 and B+2 and B+3, just for, you know, a name. And each one of those numbers could correspond to an energy reduction program, to where if I'm in reduction 1, these circuits get turned off or pulsed. If I'm in energy reduction 2, these circuits get controlled differently. We don't just pull everything off of 1 or 2 fuses anymore, especially since most of it's module controlled. We can turn everything on and off. A lot of cars, you push the horn button, you're not doing any circuits to the horn. You're just giving a signal to the computer, and the computer's completing the circuit. So some different things. I think that's all of them. So let's keep moving. So rear cross traffic. This one, you're going to see a couple of different aspects of it. The ones you see on TV where the guy's backing out of the driveway and the little kid comes up on a push car, they're not going to talk about that one on this particular video demo. Just understand that, yes, some of the systems might only pick up moving vehicles, which tend to be a little bit of the older systems. The newer systems are much more sensitive. They're going to recognize many more things. Rear cross traffic alert. Those tend to be the 2 biggest names that you'll see.
The Rear Cross Traffic Alert function, or RCTA, that is available on select Toyota vehicles, warns drivers of oncoming cross traffic, helping them avoid unexpected collisions when backing up. RCTA is part of a safety system that also includes the blind spot monitor, both of which use the same radar sensors located inside the left and right sides of the rear bumper to detect vehicles within the monitored areas. Both features can be turned on or off using a common switch labeled BSM on the instrument panel. When turned on, the rear cross traffic alert function is operational when the vehicle is in reverse with a speed of less than approximately 8 kilometers per hour and a vehicle larger than a 125cc motorbike is approaching within the monitored area at a speed between approximately 8 and 28 kilometers per hour. The rear cross traffic alert function detects vehicles approaching laterally from the right rear or left rear of the vehicle and advises the driver accordingly if it judges that another vehicle may intersect with its own path. It does so by flashing the outside rear view mirror blind spot monitor indicator lights and simultaneously sounding a buzzer mounted in the rear cabin space. To give the driver more time to react, the buzzer can alert for faster moving vehicles from farther away. The rear cross traffic alert function will not react to vehicles or objects that are stationary within the approach zone or to vehicles that are moving away. For the rear cross traffic alert function to operate normally, the sensors in the rear bumper must be kept clean and clear of any obstructions at all times. The rear cross traffic alert function is only an assist and is not a replacement for careful driving. In some conditions, which include inclement weather, the size of the adjacent vehicle, and the speed at which that vehicle is approaching, the system may not function correctly. Therefore, the driver is solely responsible for safe driving at all times. The features and functions described in this video might not be applicable to your Toyota model. See your owner's manual for details. Thank you for watching this Know Your Toyota video.
Now, I don't know about you, but now that everything seems to be a truck, an SUV, a crossover, I drive a car a lot of the time, and I can't see when I back out of a parking space. So to me, this system, this is the greatest thing since sliced bread. I don't have it on any of my cars, but it has a huge purpose, you know, for that parking space, but also people's driveways and stuff. So what are sensors we're using? We're using those same radar sensors that we've used for blind spot detection. Those same radar sensors, and that's the big thing. And we've been kind of talking about this. We can utilize these things for multiple aspects. We're paying attention to this when we put the car in reverse. Those sensors go active, you back up, it picks up, and then as soon as you drop it back into drive, those sensors go into standby, basically passive at that point until you have that sufficient speed to where now they're active for blind spot monitoring. So that same thing, just a different line of code. Big benefit, accidents. How many times have you seen people racing through a parking lot and crash into a car backing out because the car backing out couldn't see them because they came flying up? More importantly, like you see on the TV commercials, the guy's backing out of his driveway and the little kid comes up on a little scooter or something like that. These things will directly impact accidents and injuries. So that's one of those things where how do we not have this on every car going forward, in my opinion. This system talked about it being a passive. It was just given a warning. The majority of the newer systems are active and they will throw the brakes on. So best of both worlds on the new stuff. So operation, it's those rear-facing radars. It's going to pick up moving objects within a certain size, space, window, and give an alert or possibly interaction if it's got an active capability. Rear cross traffic components, the radar sensors. And where are they located? Well, it varies on cars, but a lot of the time they're on those rear quarter panels, say under the tail light or just to the front of them or just below them. They're right in that area where a corner collision, they're exposed. And they are mounted. You can see on that picture, they're mounted to a bracket. Well, if this car has been in a collision and they don't get that rear body structure essentially perfect, even if they put a brand new bracket on there, it could be off millimeters or degrees, and that radar is no longer going to be viewing in the area it needs to view. What if they had a bunch of body filler on that bumper cover? Instead of replacing it, they just filled it. Or they used an aftermarket cover that was thicker. All these kind of things come into play because anything that obstructs that signal from penetrating that cover is like putting earmuffs on it. If it can't get its reaction correctly, it's not going to work correctly. It may not have to stop it completely because that would bounce it back and give me a fault code. But if it stopped it enough, if it slowed it down enough, I might not get as quick a reaction as I could or should. And if we're a system that's an active system, hey, now we're talking with the brakes, so that the ABS can apply, because even if your foot's not on it, I run those pumps, I run the solenoids, I got brakes. Again, just using things we've already got. These tend to be tied into systems that can be turned on and off, like they showed on the Toyota video. It was part of essentially the blind spot stuff. You flip that switch off, this goes away too. So depending on the system, may decide what there is and what there isn't. Haptic feedbacks and things like that. Most of these are warnings. It's going to depend on the car as to how much you get on feedback-wise, whether it's just bells and whistles and buzzers and lights, or if it's going to shake something too. Diagnosis. Everything that we've been talking about, it starts with the visual. It really, truly starts with the visual. If there's signs of damage, if there's signs of previous repairs, looking into vehicle histories, all of that kind of stuff, you've got to dig into that because that could be the cause of the problem. Now, don't write it off and say that it is, and it might not be. But then going through, looking at the fault codes, is there modifications? Because again, it's a radar sensor. It's got an expanding cone that's leaving it. If I lift the car, if I lower the car, that's going to change what it sees. If I've got modifications back there, maybe bicycles on a bike rack on the back of my Subaru has the wheels hanging off and the wheels interfere with that radar signal, it may be giving some false positives back. So there's a lot of things that could come into play that it could give false positives or put the system into an off mode because it's seeing returns that it shouldn't be seeing based on an obstruction. Plus, if I was looking at it, maybe the customer complaint is related to rear cross traffic, but I might have fault codes for blind spot detection. Because those same systems are essentially using the same sensors, I might have a fault in the one because of the nature of that system where it monitors it at versus seeing it in the other. So I might have a rear cross traffic complaint, but I might be diagnosing it through a test plan based around blind spot detection. Same sensors and just following through it. And again, weather conditions, all this comes into play. Is it covered with snow and ice? All those kind of things. Am I coming, is it a weird parking place where it's got a dip and a bump and all those kind of weird spots that you might get into? Those kind of things could have an impact. So back to a general awareness of what's going on with it. Because it is a radar, it's got to be calibrated. So you're going to go through those calibration steps with the radar sensors. If I remember correctly, thinking back to Josh in one of the early ones, I think they might have been doing one of the rears, I don't remember. And essentially it's a target in a certain location that provides that radar a certain amount of bounce back. And as long as that system gets the bounce back that it should, with everything located where it's supposed to be, the system's happy and it's calibrated. Driving and self-auto ones might not be as plentiful with this because you might not be in the conditions for it to learn. But as we've been discussing, a lot of the newer systems have, gone the full circle. They've gone from mechanical to trying to have more automated, and a lot of them are circling back to mechanical because it is so difficult to get the vehicle in the right conditions during a road test for it to calibrate, that they've defaulted back to, let's get a target on it so that we can be sure that we can calibrate it correctly. And again, that was a pretty easy system. So let's see where we got here. Let's see here. Scrolling my way back up here. So Steve K saw a Chevy ad that will fill in the picture when a trailer is attached to the truck when in reverse mode. Any idea how that system works? Will it fill in the picture object closest to? Actually, I do know how it works. There's another camera. There's an accessory kit you buy, and you mount another camera at the back of your trailer, and that hardwires in through the switch, the plug connectors, and it has to be a GM connector. You've got to activate the system in the programming and everything. And essentially it superimposes the camera picture from the back of the trailer instead of the camera picture from the back of the truck. And that's also a key thing to keep in mind. With a lot of these systems, if you have installed a factory trailer or a trailer hitch assembly and the factory wiring, and that's the big piece, going through and getting the factory connection assembly and doing the programming, because that's when it says, oh, you plugged in a trailer, I'm going to ignore the rear park distance control. Oh, you plugged in a trailer, I'm going to ignore the backup camera. I'm going to ignore the cross traffic, things like that. So you could have some situations where the customer went to U-Haul, had a hitch installed, did some aftermarket wiring, and now they have a bunch of these weird problems going on. It's because the system doesn't know that there's a trailer there. It thinks somebody's on their butt. So that's a big thing to keep in mind. Mark, it saved me from people speeding behind me in a parking lot. Yeah, I mean, how many times have we all had that oh no mode because you see somebody flying up at the last minute? Josh, I think that's the one where you have to install the rear view camera. Yeah, so we talked about that with Steve's. Steve K, sometimes you can get a false warning, but better than an accident. Exactly. I'd rather I stopped or the car stopped than run over the little kid. That's a big one. Mark, go, no go template. On the body collision side, nowadays the systems are extremely advanced. And they can go in there with practically like a laser sensor type of thing. It's a measuring system to where they can go in there and put something at a certain location, and they've got specifications within the hardware that basically measure to a precise amount and say, this is in spec or this is out of spec. So it's a matter of how good of body work are they going to do. And again, one of the things that the collision side is already seeing is a higher number of vehicles being totaled that have these systems. because the insurance companies know that they have to come back to such precision for all these systems to work correctly, that if they don't get it perfect, they expose themselves to liability down the road. And the insurance companies are saying the heck with it, and they're totaling the vehicle. Now, that's a good thing. The bad thing is those totaled vehicles are going into salvage or going into auctions, and they're getting the body shops that are buying them up and fixing them, you know, and putting them back into service. And then when things don't work, hey, that's your problem. I had a former instructor that told me a friend of his had bought it happened to be a BMW. He bought it at an auction. The car was in immaculate condition, sold as a salvage, and it had the whole dashboard lit up like a Christmas tree because it needed all of the ADAS systems calibrated. So he tried to take it to the dealer. They said, no, flat out, no, we won't touch it. Took it to multiple body shops. For the most part, they said, no, we won't touch it. He finally found one that would come in on a Saturday with the doors closed kind of thing, and ran through and calibrated everything. It took him all day long, but they got everything calibrated. He's driving, it works great. So in that car's case, it got fixed enough that everything would calibrate and work correctly. But that's the risk that people are going to take now if they're buying salvage vehicles, or, you know, we all know the flood cycle of used cars that come in. All of these are systems that, yeah, the flood might not have, bent something, but now there's that many more things that have water egress or ingress that could be a problem. So, you know, it's not getting less on the things that we're going to have to deal with collision and damaged vehicles. It's going to get more. But hopefully these systems reduce the number of total accidents in the first place, and it becomes less of an issue. Mark, the Audi field rep had me isolate the sensors with aluminum, with white aluminum tape for a customer concern. You know, I've done that in the dealer level. I remember a fix with BMW where the third brake light, the way the wire was routed, it interfered with one of the radio antennas. And you would take it and you would insulate it with like an aluminum tape. So you do get some feedbacks on different things. I don't know that I would want to have the little itty bitty CAN wires that are coming off this sensor routed next to a battery cable. I could probably have some induction problems there and start getting some really weird faults. But I don't think it's a concern for the car that hasn't been altered, the car that hasn't been fixed, the car that hasn't been modified, because things are already where they should be, because the manufacturer's already figured that out and dealt with it. In those few cases where the manufacturer after the fact has a problem, that's when they go back in there and they give you that field fix. Hey, reroute this, wrap it with aluminum foil and duct tape, and, you know, put it back together, because those fixes exist. We've all done it in the dealer.
That car, it had a bunch of false alarms. When you just drive by buildings, all of a sudden it would flash, you know, like someone was next to the blind spot detection. And so, yeah, that's what he tried to do, I think, is put swaths of the stuff where we'd wrap different things in the back. It was kind of a new system, I think, and so we're experimenting with what would fix it. It eventually was one or two of the radars. I think we had to buy it as a matching set, which fixed it.
Yeah, I remember I worked in a dealer in San Jose, and we had a customer that worked up by that big radar dish near Stanford, and his car would do all kinds of weird stuff only there. I had another customer whose car would do weird stuff every time an airplane flew over, you know, and he was having problems with the garage door remote too because of radio frequencies. So
hey, do you remember the Rabbits back in the day, that if the Volkswagen Rabbits, if they drove by a truck, a semi, and that guy hit on the right CB channel, it would knock out the ignition?
I hadn't heard that one, but I've had all kinds of weird stuff, you know, a lot of CBs talking over my car radio. I know a lot of the Europeans, God, it was probably 10, 15 years ago, there was a bridge outside of Woodcliff Lake in New Jersey, and everybody was having the same problem. The car would get on the bridge and the whole screen would go green. And they each individually, they couldn't figure out what the heck was going on. And they happened to all be at the same restaurant, a bunch of them talking to each other. Oh yeah, ours does that too. Ours does it. And they come to find out that they all ran the same mapping company and the map was blank. And they said it was like a 100-year-old bridge. How could they not have that road on it? Well, that map happened to be blank in that section. And that's how navigation would respond, is when it was somewhere it didn't know, it went showed a green screen. We see that now when they build a bridge and there's water there, you drive through the water on the nav screen, even though you're on a bridge, or you're driving through a field in a new housing tract because the map's not up to date. There's a lot of weird stuff, that comes out in the log. Steve K, my son had a 2018 GMC pickup. It's lifted 6 inches, not too much change in the picture or warning, pretty good field of view. Yeah, on a rear backup camera, the big thing is what he probably has an issue with is if it has the park distance lines or the targeting lines, you know, the ones that kind of sweep to help put you in a parking space. Those would probably be most effective because it's not looking at the ground at the same angle, it's looking much higher. So that would be one thing. I don't know if you could get away with just, you know, putting a bunch of wedge shims on it and just tilting the camera down. But Ed, amazing that the initial visual inspection is so important and it's something that should be taught to our students for all systems. Yeah, you know, forever we've always said you got to duplicate the complaint. Okay, you duplicated the complaint, you're checking for fault codes, you're checking your bulletins and all that kind of stuff. And with all of these systems, that next step is I got to do a visual. Is it missing? Is it modified? Has it had paint work? Because all of those things impact cameras and sensors. And that's why, you know, a big piece is now teaching how to recognize collision stuff. You know, what does factory paint look like? I mean, we're all in this call old enough that know that orange peel is not good. Well, the reality is every new car has orange peel because of the way the paint is now. You know, it's water-based paint, it's water-based clears, it's water-based primers. So every car has essentially orange peel that 30 years ago, we would have said that's a terrible paint job. Well, how do you tell a car's been repainted? Well, they do make a tool that's like almost like an ohm meter that they can go on and they touch the paint in different parts of the car. A lot of the time they'll start with the roof because that's one area that's least damaged. And it essentially measures paint thickness. So that's one way to do it. But the other thing is to look at the consistency of the paint finish. So if you're looking at this car with good daylight and you see a big section that's got nice consistent orange peel, and all of a sudden you see a smooth section, guess what? That's been repainted. Because the body shop, they're going to put a bunch of layers on, they're going to color sand it down, they're going to put some clear on it, they're going to color sand it down, and they're going to have a smooth finish, not a orange peel finish. If they're a good body shop, you won't see the sanding marks. You won't see the outline of the fillers. You know, if they're a really good body shop, you won't see the runoff from the color sanding inside the carpet and under the panels. They'll remember to take all the part stickers off the panels that are underneath and things like that. There's almost always an indicator that you can find that a car's had paint and collision work. That shop that does that $20,000 paint job restoration thing that did the whole rotisserie stuff, you still might know that it's not the right paint job, but they did a really good job and you're not going to get those obvious indicators. But that's a bigger part. Let's see. Keystone has a contract with GM. Who's Keystone? So Jesse, you'll have to, there's a little bit more. Mobile RVing. Jesse, if you can pop in, fill in some gaps with that one. Michael Ford has that on the Super Duty and is adding it to the 20. Yeah, I think everybody's going to have it. The cameras are great. Hopefully I'll come across Jesse's fill in here. Mike, would be interesting to see if I cover a sensor with paper, will it still calibrate? I think it depends on how much thickness, because I think the reality is if you had just a film of dirt and the system went dead, that's not real practical. But they also don't tell you how much stuff before it doesn't work. So you might start with one piece of paper and just keep going and see how thick it takes before it stops working. And I think
the reason I bring that up, remember when fiber optic came out?
Yes.
Fiber optic was supposed to be very sensitive, and to put faults in, a lot of times we had to not one coat of whiteout, but 2 coats of whiteout with dry time in between to actually block the light. And you could actually take fiber optic, and we found out tying it into a knot, it still worked.
Yeah. And I think that the radar is pretty robust as well. But I think that, you know, they're playing safe and saying, hey, if there's stuff over it, it might not work. And I think that's their easy way out with it. If there's something on it, it might not work. How much stuff, they're not going to tell you. Because what if it had less than that amount and the car got in an accident? Well, you said it could have 1/8 of an inch and it has 1/4 of an inch. Well, then the density of the stuff. I mean, if you went to Tahoe and came back, was it just ice and snow, or was it all that road grime and sludge and gnarly stuff? You know, I think it works until it doesn't. And with paper and things like that, it might be able to get much thicker. It may not have much return. But if I had more dirt and grime and rocks, I have a better chance of return and probably would trip it quicker. So D, all the above. Ed, measuring the thickness of paint applied has become an issue. Yeah, there's a very, very thin layer of paint on vehicles now. Body filler on the plastic bumper covers is going to cause a lot of these systems to have problems from everything I've read. Mark, I remember a used car sales manager having an electronic device that would detect paint thickness. Yep, that was it. Like I said, it's like an ohm meter. They walk along and just kind of touch it against the body, and it gives them a number, and they know what the factory paint thickness is, and anything more than that basically tells them instantly it's had paint and collision repair. The challenge is the ones that have had it at the port repaired and it was sold, you know, they fixed it at the factory, and it comes out thicker, and that's running. Keystone has aftermarket parts. Okay. Yeah, you're starting to see some companies that are going to come out with aftermarket sensors. We'll see how they are. You know, from the manufacturer standpoint, you know what their answer is going to be. If it's not a factory part or a factory approved part, it's not a warrantable item. It's not our problem, you know, and they're going to push it off. The challenge is going to be the collision in the insurance industry. You know, we all see what they wanted to do with glass. They want to do aftermarket glass. Well, now with these newer glass having prisms for rain sensors, having camera mounts, all that kind of stuff, that aftermarket glass creates problems. So they're having to pony up for the factory materials. And a lot of the body parts are having to be factory stuff because of these. So, you know, that may be an issue for the manufacturers and the insurance companies. James Williams, we had issues with the GPS sensor mounted to a tractor used to mow weeds out on the airfield. Times the system would begin to report jargon and computer code, which caused the system to malfunction. Turned out to be interface from the airport radar. Yeah. Finally stopped using the system for this reason. Yeah. You know, radar puts out a lot of juice, you know, from an aircraft and the commercial side. The car's not as much. But yeah, it's going to lay over all that stuff. Keystone RV trailer manufacturers. Okay, good. Nice to know. Philip Torres, being here in California, do you think even minor aftermarket mods performed by the customer independents will release the OE from liability? You know, here in California, we know how the court system is, and they're pretty liberal about things. So I think on some aspects, the manufacturer has an argument saying, hey, you didn't use a factory part. I don't know what the quality of that part is. I don't know the operational functions of that part. We've got, you know, tons of data and hours and testing and and you, what can you show? And a lot of the time, these aftermarket part manufacturers don't have that depth of stuff in it to be able to compete. So yeah, you know, if I'm Toyota and I'm getting sued, I'm probably still going to have to pay something, but it may not be as much as it would have been if it was a Toyota part versus now that they've got this third-party part installed on there. So it just depends on what judge they're sitting in front of. But we all know that at the dealer level, they will pull warranty on things. You know, you modify, you have the engine management reflashed. Hey, your engine, your transmission, your drive line, your differential, axles, all that stuff, they'll pull the warranty off that. Your window regulator goes out, hey, we'll still warranty that, but they're not going to warranty anything related to that modification. So they're pretty aggressive about that. Peter, paint film gauge, only measure paint film on steel parts only. You know, yeah, I think it is only on metal because it doesn't have anything we react to from like a plastic bumper or something like that. And that's where, you know, when you think about it, a lot of repairs are going to involve a plastic bumper. And the body shop guy I was talking to, he said a lot of the time the insurance company wants the bumper repaired and they go to battle with them because it's really hard to repair the bumpers and have them look good without having indication of the filler. So when they get a crease or they get a puncture hole, oftentimes they want it fixed, and it tends to leave that little spot that says, oh, there's filler here and a paint job there, even if they repaint the whole thing. Ed, I imagine that the manufacturers of the actual systems will eventually make replacement sensors available in a few years. A lot of them are already out there because, we all know that very few car companies build all their stuff. I mean, Tesla is one of the few right now that builds the overwhelming majority of their own parts. Almost everybody else, they build their engines and they build their bodies, and then they buy stuff from everybody else, and then they assemble it at their plants. So, they're already using Bosch parts. So Bosch is already the guy that's making all those radar sensors, and they're providing them to everybody else, or it's Mobius, or it's Nippon Denso, or Delphi. So, those tier one providers, they're selling to the aftermarket at the same time that they're selling to the industry. It's just a case of what does their contract say? How long do they have to wait before they can sell it to the industry? Let's see here. Last one here. Robbie, is there a list of camera sensors and radar manufacturers that are more attractive to auto manufacturers? When you look at what the majority of the parts in the cars, you're looking at Bosch, Delphi, Mobius, which is a lot of the Kia and Hyundai product, and Nippon Denso, which is a lot of the Japanese products. Everybody buys from whoever's the best price and has got the right part for them. But those are the main four that I hear of on most things. Are there others? I'm sure there are. But those seem to be the ones that you see the most stuff about. But you're going to have to go to the individual level to see who's using what out there. Okay. That was the last of those. Oh, go ahead. Somebody had something. No? All right. All right. Night vision. Night vision, if you haven't driven a car with it, is really cool. Hopefully you have all the other ADAS stuff on your car, because you're going to be spending so much time looking at everything on the night vision that you might crash, because it is pretty cool to watch. Mike Sherburne and I, we were taking one back from Southern California, and we were driving Grapevine, and you could see the brakes just lit up like Christmas trees on the trucks around you from the night vision. And we were coming down the long grade before you come into that little town on the bottom. And way out in the distance, we could see the hill, and it was lit up like daylight because of all the rocks and everything. So night vision, it's impressive. And it's going to take your eye away when you first use it. But in my personal opinion, it's one of those things where if you're going to have an autonomous car, I think this night vision is a gap that's desperately needed to be covered. So let's find out more.
The night vision system, providing human and animal recognition, warns against people or animals at night. To do this, a thermographic camera scans an area in front of the vehicle. People or animals from a certain size are correspondingly recognized by the system. As soon as a person or animal appears in the warning range, a warning is signaled. In case of an increased danger of collision, there is an acute warning with a warning signal. Additionally, a thermal image can be displayed in the control display.
So that's just a very quick one. And I just saw Robin had chimed in. Robin probably has some collision background. He said, so if you spray a steel coupon, basically a steel template piece, and maintain the same viscosity of paint on plastics and use the same technique, you can establish a proper film build by measuring the coats on the coupon with the electronic thickness gauge. So that's a way to where if I was measuring a plastic bumper, I could compare it with the metal on the car. If I'm a body shop that's, really, really concerned about making sure I have the right thicknesses on there. So that's a good answer. Thank you. So night vision. One of the big challenges we have is, we're human and we don't see that great at night. And no matter how good our headlights are, we can have lasers and we can have LEDs or xenon or whatever. National Transportation Highway Safety Administration, they still say our headlights suck in most cases. So we can only see so far. Night vision is one of those things that takes that distance and almost doubles it that quickly. It really creates in a completely different environment. And that's why I mentioned from an autonomous vehicle standpoint, night vision covers a gap that we have in systems. Okay, and we can look at, who was it? Wasn't Waymo. I can't remember which company it was that had that van about 2 years ago in Arizona that actually impacted a person crossing the street in the dark at night. So the radar should have picked them up. The cameras, they don't see that great at night. They don't amplify light that great at night. And remember, the driver was looking down, doing something on their phone and not paying attention, though the driver might not have seen him either. It was a pitch black area and the person came out suddenly from the side. Night vision would have seen them hundreds of yards before that. LiDAR would have picked them up a larger distance back as well. So this is one of those things where, you know, we've talked about, you know, natural conditions, the sleet, the rain, the snow, all those kinds of things. They're going to impact LiDAR. They're going to impact radar. They're going to impact cameras. The impact on night vision may not be as much because night vision from the automotive application, we're looking at thermal. So night vision kind of fits a gap in there that could resolve some problems or weaknesses in some of those other cameras and sensor systems. So it gives us that opportunity to see beyond the headlights. And again, it's right back to it's passenger, it's safety. It's safety for everybody in that car. It's safety for the cars around you. It's safety for the pedestrians. And it's a camera. It's a little itty bitty thing that's, you know, when you put it in your hand, it's, you know, twice the thickness of a Zippo lighter kind of thing. It's not a huge device on a lot of these newer systems. So it's using that camera and it's giving a passive feedback. It's giving you warning lights, maybe some sounds, maybe some haptic, but it's telling you something's there that you can't see and you're not going to see for probably another second or two until you've decreased that gap. So what's it using? Well, the earliest systems, and the Cadillac had this a long time ago, believe it or not, and it was a thermal camera. So where it was looking at a heat signature, purely a heat signature. The modern systems are using flare or forward-looking infrared radar. Still heat system, but it sees a little bit better, it sees a little farther distance, and it sees with a better detail. Let's use that term. What they've done with most of these systems, though, is they've integrated them in with an algorithm. So it sees that person. And if that person's standing there, yeah, you're going to see their thermal image outlined, but you're also going to, in most cases, get a little LED that comes on with a hyperimposed picture. Is that person standing still? Or if they're walking right to left, you know, it'll show the guy like walking one way or show the guy walking the other way to give you an idea of direction as well. Animals, in the case of BMW, these systems were actually programmed market specific. So that programming would recognize a moose in Canada, a deer in the States, and a camel in the Middle East because of the heat signature profile. And that's the superimposed warning it would give. So they are using more than just a camera to give that information. And in some cases, some of these systems, you're talking 1,000 feet away that it's picking up that initial heat signature. 1,000 feet away, you've got time to react. You haven't seen them with your headlights yet. And you're now recognizing them. Now, some people are saying, well, what is this like the military light stuff? No, the picture you see on the camera or on the display tend to be in that grayscale. This is not like you see in the movies. It's not green, you know, night vision, or in the really new movies where it's kind of that whitish blue. Okay, the military, their nods or their NVGs, night vision glasses or night vision devices, they're not thermal. They have had some versions that were thermal, but the modern versions are not thermal. They're light amplifying. So they're using a camera-like system to take existing ambient light and increase it and provide that to you. So when you watch that movie and you see they switch to night vision and that you see that green screen, that's an amplified ambient light. Well, what if you're pitch black in the middle of nowhere? There's not a lot of light other than the moon and the stars, but even those aren't that bright sometimes. In the military side, they'll have IR sensors or IR lights essentially on their rifles, which produces like a laser beam or a light that they can now see with. The white phosphor ones, instead of giving a green shadowed image, the white phosphor ones are basically giving more of a white and gray, which is a little easier on the eyes to see. So the military stuff is different. It's light amplification, but they do have some that are thermal. Cars, we're using thermal. Components, it's a camera. That's the main thing. We've got that camera. It tends to be mounted in the center of the grille on a lot of these vehicles, so fairly high up so that it can see well. Again, they're not very large. The lens on many of them, I would say, it might be a 1 inch round, probably closer to 3/4 inches of a round. And the little box that it's connected to, like I said, a couple feet Zippo lighter type of thing. So maybe a couple inches by an inch type of box that camera is mounted to. In most cases, that camera is the module. And you'll see that, with the radar sensors and things like that. They are a module in itself. And the diagram I'm going to show you in a second really runs that home. Night vision is usually one that you've got to turn on. It's going to have some sort of a display screen, whether it's in the center of the dash, displaying through the nav indication. You've got some manufacturers that are putting that third screen in the middle of the instrument cluster. And you can see from the picture there where not only is it giving us the thermal image, but it's also superimposed that little red box around that guy, trying to draw more attention to the driver. And when we were talking about adaptive lights and things like that, we saw that one system that would spotlight. Well, that spotlight system was tied into the night vision. The night vision would pick it up and it would connect with that spotlight system to highlight that person with the spotlight. So not only did you see them on the night vision, but now you see them with the headlight, that bright imposed headlight as well. There's going to be displays, whether it's through the cluster or through the navigation display. I don't know if they're on the heads up. I think it would be great if they did. If somebody knows somebody put it on the heads up, let me know. But, I threw it on there just in case. Maybe not today, but probably tomorrow kind of thing. So diagnosis. Back to our visual. We're looking at that grill. We're looking at that camera. But here's the diagram. And you've seen me from day one say, it's basic electrical testing. It's power, it's ground, it's a signal. So this particular diagram's off of, I can't remember, it was Shopkey or ALLDATA. So these things are out there. There's actually large ADAS sections on a lot of vehicles in Shopkey and ALLDATA. So this happens to be out of a BMW because I knew it would have it. So that's the reason I went after it. And if we look where it says electronic night vision module, that is the camera and module assembly. So that's located up in the front of the grille. And you can see it's got 4 wires, a power, a ground, can high, can low. So my electrical testing, do I have power to the module? Do I have ground to the module? And do I have my CAN bus communication? If I've got all that electrically, I'm good. Could I still have a hardware problem with the module or the camera? Yes. Could I have a software problem inside of it? Yes, but those usually are not a programmable module. So if it's bad internally, software or hardware, it's a new part. There's your diagnosis. Now, its results, the sensing it's making, it's transmitting that information over CAN. And it's going to whoever that system is directing it to, whether it's a instrument cluster or a master module that's controlling all the ADAS stuff, or maybe it's going straight to the display. That's it. And if you look at the radars, you look at the other cameras, you're looking at almost that same kind of thing on all these different systems. It's a power, it's a ground, and it's a bus connection. And in this case, it's a CAN. CAN high, CAN low. So reinforcing the needs for that fundamental, that new basics of, you've got to be able to use a DVOM. You've got to be able to use an oscilloscope. You've got to be able to use a scan tool in every class. There's application in every single class with these systems. And the flow chart. And notice it's pretty much empty. what I would do if I was teaching this in a class, I would say, okay, customer complaint is night vision doesn't work. What are you going to do first? And literally with the class, you could build that flow chart. Do I have an image? Yes, no. Does the image change when I put something in front of it? Yes, no. You could build that out just through a verbal discussion with them or a picture of a diagram with them. If they understand it, they can create that flow chart. If they truly understand what's happening, they can build that flow chart. That's that point where you now have a technician who can diagnose. That's the ultimate goal. Now that might be an 8-year technician, but we can help them along with that understanding. If they understand how it works and they understand that, hey, I check my power, I check my ground, I've got communications. I might have a hardware issue here, or I might have it someplace else. I check it on the other end. I got the same thing there. Hey, now I'm looking at that camera. So it's not as complex as we want to make it. It's a lot simpler. It's just back to those fundamental pieces and back to getting in with scan tools, getting in with this stuff, really learning it. You know, for a long time, too many of us said theory was unimportant. It's all about their hands. No, they got to know what to look at, because if there's no fault code, they're lost. And the manufacturer doesn't want them swapping parts. So back to really understanding how it works. You might fix it before you had to touch anything. Modifications, well, if you raise and lower it, you've changed that sight cone. You know, if the car is off thrust, you've changed that sight line. You know, not too many people are putting clear coats over bumpers, but you do see people putting in aftermarket grills. They put an aftermarket grill on this thing. Maybe you covered the camera. A lot of different things that can come into play when they start getting modifications. Weather conditions, like all these other systems. If I've got really, really heavy rain, is night vision going to be seriously impacted? Not so much, because if that deer's out there, it's a lot warmer than the background. Same thing with sleet, snow, hail, fog, smog, dust, everything else. It's a thermal image that I'm looking at. The challenge could be is the clarity. You know, it may be a little bit foggier between me and them if it's all impacted and built up with ice, but you know, if it can, I'm still going to see a heat signature there that I wouldn't see with anything else. So it is a pretty robust system, but they are expensive. Everything I've seen on option wise, it's like $5,000 or $6,000 option just to add night vision in a lot of cars. Calibration. The calibration on this is pretty straightforward. There are some of the ADAS calibration units that they'll have that has a targeting that you would set up for it. But with some of them, it's literally that headlight aimer like I showed last week, where that's how you're setting up the camera, is more with a headlight aimer. It's not so much about reflective targets or anything like that. It's kind of a spot point A target type of thing. People are curious about sensitivities. Right now, we're on about probably the 3rd or 4th generation of night vision. When we first saw night vision, 2002, 2003, we had a car parked in a stall, had a power supply on it. We were teaching night vision. You know, you put a cup of boiling hot water in front of it, and lukewarm and cold water, and you wave your hand and all that kind of stuff, and everybody goes, ooh, ah. And we saw this little line, you know, a lighted line that literally went right down the middle of the screen. We couldn't figure out what it was. And then all of a sudden, somebody was at the front of the car and it went away. We're like, whoa, 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 what did you do? All they did was they turned off the power supply. What we were seeing was the temperature difference between the power cord for the power supply and the drywall that it was laying in front of. It would give us that faint line. This was 2002, 2003. That's how sensitive these systems are. That was a first gen for automotive. We're now 2 or 3, 4 generations later. These systems, they can't even sell them in, it's about a dozen countries around the world, because they're worried about the weaponization. So they can't sell a car with the system. They can't sell the parts, none of that, because they're worried about the capabilities of weaponization of it. It is a highly sensitive system. In some of them, you can replace lenses. Oftentimes you're replacing the assembly. You might need to go through and carefully clean the lens. It does have a face surface on it that's very similar looking to a ultrasonic sensor. You know, it's not that fisheye, you know, type of glass sensor lens. It's more of a muted matty colored lens. So it is a little bit different. But for the most part, you know, you're calibrating it like you do a headlight in many aspects. So let's see what we got here. Ed Snyder drove one of the 7 Series with night vision, found it would not pick up on the heat signature of the butterflies crossing the road in farm country roads. Yeah, there's not a lot of heat in a butterfly. But if it was a duck or something, you would have seen it.
Yeah,
Edward Worth, does it pick up exhaust pipes or is that above the range? You know, I'm trying to think back if I saw exhaust pipes. I don't remember noticing it, but I don't think there's a high end on it. Because like I said, we could see brake rotors on trucks glowing, you know, like the sun. And I'll bet that those trucks coming down Grapevine, they were right there with exhaust temperatures too in some cases. So I don't think there's an upper threshold on it. It may not show a different color after a certain point, but they're sensitive. It shows a lot. Like I said, you could see in a field, if there was a rock that had been in the sun all day, you can see the rock. So it might be black all around it, and then you see this glowing rock because of the heat that it held compared to the background around it. Ed talked about the cup of water. Yeah, we used to do that. That was a regular thing, you know, waving your hand in front of it, everybody in the car going, oh, that's cool. You know, it is a neat thing. Mark, the manufacturer had me swap parts frequently. Yeah, a lot of these systems, if you've got power, you've got ground, you've only got two, in signal, you've only got 2 options. It's either hardware or software. In the case of the night vision cameras, they're not reprogrammable. You install it. If it wasn't reprogrammable, then yeah, the next step would be you update the software in it and see if that fixed it. And if it still didn't fix it, yeah, now you're putting hardware on. Mike Hernandez, does the system display the heat variances or does it display the object shape? What I've seen with them is it's going to give you that body outline, but you will see parts of the body that are brighter than others. So let's say they're wearing a jacket and pants. They're going to be a little dark. You'll see their entire body outline, but they'll be darker kind of in the middle, but you know, like their face and their arms, where there is skin, you will see more concentration than where there's less heat. Does that make sense? It's not just purely a silhouette. You can see some temperature difference. How extreme it is depends on what all they're wearing and things like that. Animals tend to be a similar temperature through all the body mass. So like if you see a deer, you don't see the legs as much, but you see the center mass.
The reason I'm asking is I was under the belief that part of this system is it's kind of object oriented. So it kind of looks at the variances in heat and kind of determines what shape it best represents.
Yeah, and that's what it's doing. Is it's kind of looking at that shape and it says that shape looks like a human. Now, I guess if you're Bigfoot, it's probably going to say that's a human. But, you know, small animals, you know, dogs seem to be dogs, cats seem to be cats. Bigger than that seems to be a deer, you know, but if it's a moose or a horse, it's probably going to be the same superimposed picture. You know, cows, I haven't seen a cow on one yet. So it might just come up as a, you know, a big heavy dog or a small horse or something. But it may not give you a superimposed algorithm. It just may give you the silhouette of the object and a warning that, hey, there's something there. Does the screen only light up when a threat is detected? No. On the systems I've been in, when you select night vision, it's on all the time. So in the case of like the BMWs, it was in the navigation screen. When you had night vision on, all you saw was night vision. You did not see your navigation anymore. I haven't been in one like, I think it's Mercedes and maybe Audi that use the screen in between the instrument cluster to superimpose there. But I would kind of assume that anything that would have been projected there is not projected there when the night vision's on. From what I've seen with them, night vision, when it's on, you see it all the time. Wow. Anybody else? Cool. Hey, that's pretty good time, 2:38.
Wow.
Usually we're worse than that, so we're sitting pretty good. So thanks again, everybody, for coming. Next week we've just got 2 topics: traffic sign recognition, which is pretty cool, and it's a big piece of the autonomous movement. And then we're going to talk about autonomous. Autonomous will take a little bit of time for us because, you know, whether we're talking semi-autonomous or autonomous, those are kissing cousins, and we're getting there fast. We're getting there real fast. These cars, at this point, we've talked about everything you need to have for an autonomous vehicle, with the exception of different hardware and the algorithms. But other than that, if anybody's got any other questions, throw them in there, and we'll see you next week unless Pam's got something she needs to say.
No, I sent out an email to everyone with all the announcement follow-ups that we discussed at the top of our conference call today. But if you have any questions, whatever, you know where I am, get in touch. Thanks, everyone. Kurt, as always, thank you.
Yeah, thanks a lot. Thanks, everybody.
Take care. Be safe, everyone.
Thanks, Pam.
Thank you.
Thank you.
Mm-hmm. Probably go ahead and turn off the recording.
Yep.